Every night, we journey into a world crafted by our own minds. A world where logic bends, time twists, and emotions run wild. This is the world of dreams, a realm as familiar as it is mysterious. But why do we dream? What happens in the hidden theaters of our brains when sleep descends? These questions have captivated humanity for millennia. From ancient civilizations interpreting dreams as divine messages to modern science probing the intricate workings of the sleeping brain, the quest to understand dreams has been a constant thread in our intellectual tapestry. We are drawn to the enigma of dreams, compelled to unravel their secrets and decipher their meaning. Join me, fellow explorers of the cosmos, as we venture into the fascinating world of dreams. We will delve into the history of dream interpretation, explore the latest scientific discoveries, and unravel the mysteries that lie within the nightly cinema of our minds. The ancients believed that dreams were messages from the gods, glimpses into the future, or journeys of the soul while the body slept. Shamans and oracles interpreted dreams to guide decisions, predict events, and heal the sick. Dreams held a powerful sway over ancient cultures, shaping beliefs, inspiring art, and influencing the course of history. Today we approach dreams with the tools of science, seeking answers in the intricate workings of the brain. While we have shed the mantle of superstition, the fascination with dreams remains as strong as ever. Modern theories, drawing from psychology, neurology, and evolutionary biology, offer compelling explanations for why we dream. Some theories posit that dreams are a manifestation of our unconscious desires and fears, a playground for our deepest emotions and repressed thoughts. Others propose that dreams are merely the brain's way of processing information, consolidating memories, and making sense of the day's events. Still others suggest that dreams serve an evolutionary purpose, helping us rehearse for potential threats and enhance our survival instincts. In the early 20th century, Sigmund Freud, the father of psychoanalysis, revolutionized our understanding of dreams with his landmark work, The Interpretation of Dreams. Freud believed that dreams were the royal road to the unconscious, a window into our deepest desires, fears, and motivations. He argued that dreams are a form of wish fulfillment, allowing us to experience desires that are unacceptable or unattainable in waking life. Carl Jung, a contemporary of Freud, expanded on this psychoanalytic view of dreams, proposing that they serve a compensatory function. Jung believed that dreams help us integrate our conscious and unconscious minds, providing insights into our shadow selves and guiding us towards psychological wholeness. He viewed dreams as a source of creativity, spiritual growth, and personal transformation. While Freud and Jung's theories have been influential in shaping our understanding of dreams, they have also been subject to criticism and debate. Some argue that their interpretations are too subjective and lack empirical evidence. Nevertheless, their work laid the foundation for the psychological study of dreams and continues to inspire research today. Section 4. The Brain Symphony, a Neurological Perspective. As our understanding of the brain has advanced, so too has our understanding of dreams. Neuroscientists have identified specific brain regions and neurochemicals involved in dream production. During REM sleep, the stage of sleep most associated with vivid dreaming, the brain displays heightened activity in areas involved in emotion, memory, and visual imagery. The neurotransmitter acetylcholine, known for its role in learning and memory, is particularly active during REM sleep, suggesting that dreams may play a role in memory consolidation. Conversely, levels of serotonin and norepinephrine, neurotransmitters involved in logical thinking and attention, are suppressed during REM sleep, which may account for the bizarre and illogical nature of dreams. Modern neuroimaging techniques, such as fMRI and EEG, allow researchers to observe brain activity during sleep and dreaming in unprecedented detail. These studies have revealed fascinating insights into the neural correlates of dreaming, shedding light on the brain mechanisms that underlie our nocturnal adventures. Section 5. The Evolving Dream, Survival, and Beyond. From an evolutionary perspective, dreams may have played a crucial role in our survival as a species. The threat simulation theory proposes that dreams serve as a virtual reality simulator, allowing us to rehearse for potential dangers in a safe environment. By confronting threats in our dreams, we may be better prepared to face them in real life. Furthermore, dreams may have contributed to the development of our cognitive abilities. The proto-consciousness theory suggests that dreams, with their bizarre narratives and emotional intensity, provided an early platform for the development of consciousness, imagination, and creativity. While the mystery of dreams is far from solved, we have made remarkable progress in understanding this enigmatic aspect of the human experience. By combining insights from psychology, neurology, and evolutionary biology, we are piecing together the puzzle of why we dream. Dreams offer a glimpse into the inner workings of our minds, revealing hidden desires, processing emotions, and perhaps even preparing us for the challenges of tomorrow. As we continue to explore the world of dreams, we unlock not only the secrets of our sleeping minds, but also the mysteries of consciousness itself.
Did you know that a group of scientists once stayed awake for 11 days straight? They wanted to see what would happen to the human body without sleep. It turns out a lot. Sleep is like a power button for our brain and body. When we close our eyes and drift off, our internal systems don't just take a break. They kick into overdrive. As we sleep, our brains are busy cleaning, repairing, and preparing for the next day. Our muscles relax, our breathing slows, and our heart rate drops. It's like our body's way of recharging its batteries. Why is sleep so crucial? Imagine trying to run a marathon without stopping to rest or refuel. That's what it's like for our bodies and minds. When we don't get enough sleep, we become sluggish, our thinking gets foggy, and our mood takes a nosedive. Sleep isn't just about feeling good. It's essential for our physical and mental health. Sleep isn't just one long, uninterrupted snooze. It's a dynamic process that cycles through different stages throughout the night. These stages can be broadly categorized into two main types: non-REM sleep and REM sleep. Non-REM sleep is further divided into three stages, each progressively deeper than the last. Stage 1 is like the entryway to sleep, that light doze where you're easily awakened. As you progress to stage 2, your brain waves slow down and your body temperature drops. Finally, stage 3, also known as deep sleep, is where the real magic happens. This is when your body releases growth hormones, repairs tissues, and strengthens your immune system. After deep sleep comes REM sleep, the star of the show when it comes to dreaming. During this stage, your brain activity ramps up, your eyes dart back and forth beneath your eyelids, and your muscles become temporarily paralyzed. This paralysis is nature's way of preventing you from acting out your dreams. As the night progresses, you cycle through these stages multiple times, with each cycle lasting around 90 minutes. Sleep is like a nightly tune-up for our brains. During sleep, our brains work tirelessly to consolidate memories, process emotions, and make sense of the day's events. It's like our brain's way of organizing its filing cabinet, storing important information and discarding unnecessary clutter. This process is crucial for learning, memory, and even creativity. When we don't get enough sleep, our cognitive abilities take a hit. We struggle to focus, our attention span dwindles, and we become more prone to making mistakes. But the benefits of sleep extend far beyond our brains. Sleep is also essential for our physical health. During deep sleep, our bodies release growth hormone, which is crucial for cell regeneration and repair. Sleep also helps regulate our hormones, control our blood sugar levels, and keep our immune system functioning properly. When we consistently skimp on sleep, we increase our risk of developing a wide range of health problems, including obesity, heart disease, diabetes, and even certain types of cancer. Section 4, the price of sleeplessness, health consequences. In today's fast-paced world, sleep is often seen as a luxury, something to be sacrificed in the pursuit of productivity and success. But chronic sleep deprivation comes at a steep price. When we consistently fail to get enough sleep, our bodies and minds start to suffer. We become more irritable, our moods swing erratically, and we struggle to cope with stress. Our immune systems weaken, making us more susceptible to colds, flu, and other infections. Our risk of developing chronic diseases like obesity, heart disease, and diabetes skyrockets. The consequences of sleep deprivation extend beyond our individual health. Studies have shown that sleep-deprived drivers are just as dangerous as drunk drivers, and workplace accidents increase significantly when employees are running on empty. Sleep deprivation is a societal problem with far-reaching implications. Section 5, Sweet Dreams, Embracing the Night. Sleep is an indispensable pillar of our overall well-being, intricately woven into the fabric of our physical and mental health. From consolidating memories to repairing tissues, sleep is a powerhouse of rejuvenation and restoration. While we sleep, our brains are busy making sense of the day. Our bodies are diligently repairing and rebuilding, and our immune systems are being fortified for the challenges ahead. Embracing a consistent sleep routine, creating a conducive sleep environment, and prioritizing sleep as a non-negotiable aspect of a healthy lifestyle is not just self-care, but an investment in our long-term well-being. And here's a fun fact to lull you into appreciating sleep even more. Did you know that we spend approximately 1/3 of our lives asleep? That's a significant chunk of time dedicated to rejuvenation and restoration. So tonight, as you drift off to sleep, remember that you're not just resting your body. You're embarking on a remarkable journey of renewal and revitalization.
Hey there, welcome to our deep dive into the fascinating world of viruses. Ever wondered what viruses are and how they could make us sick? Well, you're in the right place. Let's dive into the secret life of viruses and uncover their mysteries. First off, imagine a virus as a tiny, sneaky invader. These invaders are incredibly small. They're so small that millions could fit on the head of a pin. Microscopic and mighty, right? Despite their size, they can cause a lot of trouble. Viruses aren't alive in the traditional sense. They don't have the machinery to sustain life on their own. They can't move, eat, or reproduce on their own. They are essentially inert particles until they find a host. Instead, they need to hijack the cells of living organisms, like us. This is where their true power lies. Think of them as biological pirates. They invade, take over, and use the host's resources for their own benefit. Now let's talk about how they attack. The process is both fascinating and alarming. When a virus finds a host, it latches onto a cell and injects its genetic material inside. This is the first step in their takeover. This is like breaking into a factory and taking over the machinery. The cell's normal functions are disrupted. The cell starts producing more viruses instead of doing its normal job. It's forced to become a virus factory. Pretty soon the cell is overwhelmed and bursts open, releasing new viruses to invade more cells. This cycle continues, spreading the infection. This process repeats, spreading the infection throughout the body. It's a viral takeover. The speed at which this happens can be astonishing. Different viruses attack different parts of our body. Each virus has its own preferred target. For example, the flu virus loves the respiratory system, while others might target the liver or even the nervous system. This specificity is what leads to different symptoms. This is why different viruses cause different symptoms. The area they infect determines how we feel. Our body has a defense system, the immune system. It's our natural shield against these invaders. It's like a well-trained army ready to fight off invaders. Each cell in this army has a specific role. When a virus is detected, the immune system launches an attack to destroy the virus and infected cells. This battle is crucial for our recovery. Sometimes, though, the immune system needs a little help. This is especially true with new or particularly aggressive viruses. That's where vaccines come in. They are a powerful tool in our medical arsenal. Vaccines train our immune system to recognize and fight specific viruses. It's like a practice drill for our immune cells. It's like giving our army a wanted poster of the bad guys. This way they can respond more quickly and effectively. Thanks to vaccines, we can prevent many viral infections before they even start. This has saved countless lives. So, to sum it up, viruses are tiny invaders that hijack our cells to reproduce. Their strategy is both simple and devastating. They can make us quite sick, but our immune system is always on guard. It's a constant battle happening inside us. And with the help of vaccines, we can give our body an extra edge in the fight. This added protection is crucial. Remember, understanding how viruses work helps us stay healthy and strong. Knowledge is power when it comes to our health. Keep washing your hands, stay updated with vaccinations, and take care of your amazing body. Thanks for watching. Stay safe and informed. If you found this video helpful, don't forget to like, subscribe, and share it with your friends. See you next time. Stay curious and healthy.
Mountains of Fire. An introduction to volcanoes. Volcanoes are like giant safety valves for our planet. They play a crucial role in maintaining the balance of the Earth's internal pressure. They are openings in the Earth's crust, formed by the movement of tectonic plates. These openings can be small cracks or huge mountains, varying greatly in size and shape. Deep inside the Earth, it's very hot. Temperatures can reach up to thousands of degrees Celsius. This intense heat melts rock and turns it into a thick, flowing liquid called magma, which is stored in magma chambers. Think of it like very hot, melted chocolate. When the pressure builds up, this magma finds its way to the surface. Volcanoes are important because they help release pressure from inside the Earth, preventing catastrophic explosions. Without them, our planet might explode. The eruptions, though dangerous, are a natural way to release built-up pressure. Volcanoes can be scary when they erupt, spewing lava, ash, and gases into the atmosphere. But they also play a vital role in shaping our planet, creating new landforms and islands. Over millions of years, volcanic eruptions have created new land, contributing to the ever-changing landscape of our world. They also release important minerals and gases into the atmosphere, which are essential for various ecological processes. Inside the volcano. A look at the structure. Volcanoes are fascinating natural formations that have intrigued scientists and adventurers alike for centuries. But what lies beneath their majestic peaks? Imagine a volcano like a giant bottle of soda. When you shake a soda bottle, pressure builds up inside, and when you open it, the liquid bursts out. Similarly, a volcano operates under immense pressure. It has different parts that work together in a complex system. Each part plays a crucial role in the overall function of the volcano. The magma chamber is like the bottle itself. This vast underground reservoir holds the molten rock, or magma, which is the lifeblood of the volcano. This is where the molten rock, or magma, is stored. The magma chamber can be several kilometers below the Earth's surface and is under tremendous pressure. The conduit is like the neck of the bottle. It's a narrow, pipe-like structure that channels the magma from the chamber to the surface. It's the pipe that connects the magma chamber to the surface. As magma rises through the conduit, it can cause tremors and other seismic activity. At the top of the conduit is the crater. This is the bowl-shaped depression at the summit of the volcano. Think of it as the opening of the bottle. The crater is where the magma, now called lava, finally erupts. This is where the magma erupts from. The force of the eruption can send lava, ash, and gases high into the atmosphere. Volcanoes can have one main vent or many smaller ones. These vents act as additional outlets for the magma and gases. These vents are like tiny holes that release gas and ash. They help to relieve some of the pressure building up inside the volcano, preventing larger, more catastrophic eruptions. The birth of magma, deep within the Earth. Deep beneath our feet, the Earth is incredibly hot. The temperature is so high that it can melt rock. This molten rock is called magma. It is lighter than the solid rock around it, so it slowly rises towards the surface. Magma is a mixture of molten rock, gases, and crystals. It's like a giant underground soup. The exact composition of magma varies depending on where it forms. This affects how explosive the eruption will be. Section 4. The pressure cooker. How eruptions happen. Volcanoes are one of nature's most powerful and awe-inspiring phenomena. As magma rises from deep within the Earth, it puts immense pressure on the rocks above. This molten rock, known as magma, is incredibly hot and filled with gases. It's like filling a balloon with too much air. The pressure keeps building and building. Eventually, the pressure becomes too much and the rock gives way. This sudden release of pressure causes an eruption. During an eruption, magma is blasted out of the volcano with tremendous force. Once it reaches the surface, it is called lava. Lava can be very hot and dangerous, capable of destroying everything in its path. It can ignite trees, melt structures, and reshape the landscape. In addition to lava, volcanoes also release gases, ash, and rock fragments into the air. These materials can be hazardous to both health and the environment. These can travel long distances and have a significant impact on the environment, affecting air quality, climate, and even aviation. Section 5. The fiery dance. Different types of eruptions. Not all volcanic eruptions are the same. Some are explosive, like a shaken soda bottle. Others are more gentle, like a slow-flowing river of lava. The type of eruption depends on the composition of the magma. If it is thick and sticky, the eruption will be more explosive. If it is runny, the eruption will be more gentle. Volcanoes can also produce different types of hazards such as lava flows, ash falls, and pyroclastic flows. Hey there, movie buffs! Ever wondered how those magical animated films come to life? Today I'm pulling back the curtain to reveal the secrets behind your favorite animated movies. First up, we've got the script. Just like any live-action film, it all starts with a solid story. Writers and directors brainstorm ideas, developing characters and plot lines until they've got something truly special. It's the blueprint of the movie. Once the script is locked in, it's time for storyboarding. Think of storyboards as a comic book version of the movie. Artists sketch out each scene, shot by shot, to visualize how the story will unfold on screen. These drawings help directors plan the film's pacing and camera angles. Next, character design takes the spotlight. Artists create detailed drawings of each character, considering their personality, movements, and unique quirks. From the hero's heroic stance to the villain's sinister grin, every detail matters. With characters designed, we move on to modeling. This is where 2D sketches turn into 3D models using computer software. Think of it as creating a digital sculpture. These models are the foundation for animators to bring characters to life. Now comes rigging, arguably one of the trickiest parts. Rigging is like giving the 3D models a skeleton. It allows animators to control how the characters move. From a simple nod to complex dance routines, it's all about making sure movements look natural and expressive. Alright, time for the main event animation. Animators breathe life into the characters, frame by frame. Using the rigged models, they create every movement, expression, and interaction. It's a painstaking process, but it's where the magic truly happens. But wait, there's more. Once the animation is done, it's off to the lighting and rendering department. Lighting artists add depth and atmosphere to scenes, setting the mood with shadows and highlights. Rendering turns the raw animation into polished, final images, complete with textures and effects. Finally, we have post-production. This is where sound design, voice acting, and music come together. Voice actors record their lines, sound designers add effects, and composers create the score that tugs at your heartstrings. Everything is synchronized perfectly to enhance the storytelling. And there you have it. From script to screen, creating an animated movie is a colossal team effort. It takes creativity, technical skill, and a whole lot of patience. But the result? Pure cinematic magic that captivates audiences of all ages. Thanks for joining me on this animated adventure. Make sure to hit that like button if you enjoyed this peek behind the scenes, and don't forget to subscribe for more movie magic. Catch you next time. Alright, hey there! Have you ever wondered how magnets work? Yep, those little things that stick to your refrigerator or make your earbuds snap together. Today I'm going to break it all down for you in a way that's super simple and fun. So let's unlock the secrets of magnets. First off, magnets have this invisible force called a magnetic field. Think of it like an invisible rubber band stretching out from the magnet. This field is what makes magnets stick to metal objects. Now magnets have two poles, a north pole and a south pole. And here's the cool part. Opposites attract. That means the north pole of one magnet will attract the south pole of another. But try to push two north poles together, and they'll repel like crazy. Same goes for two south poles. It's like trying to push the same ends of two magnets together. They just won't have it. But why do magnets have poles? Well, it's all about the electrons, the tiny particles that orbit around atoms. In most materials, these electrons spin in random directions, canceling each other out. But in magnetic materials like iron, nickel, and cobalt, the electrons line up in the same direction. This alignment creates a magnetic field, giving the material its magnetic properties. Ever heard of the term magnetized? That's when a material gets a boost in its magnetic properties. You can magnetize something by rubbing it with a strong magnet. What happens is that the strong magnet forces the electrons in the material to line up, making it a magnet too. Pretty neat, right? But magnets aren't just for sticking things to your fridge. They're used in all sorts of cool technology. For example, electric motors rely on magnets to spin. When electricity flows through a coil of wire inside the motor, it creates a magnetic field. This field interacts with the magnets in the motor, making it spin and do work. That's how your fan, blender, and even your electric car work. And let's not forget about MRI machines in hospitals. These machines use powerful magnets to create detailed images of the inside of your body. By aligning the particles in your body, the MRI can see everything from your muscles to your brain, helping doctors diagnose and treat illnesses. So the next time you see a magnet or use something that relies on magnets, remember all these cool facts about how they work. Magnets are more than just fridge decorations. They're a fundamental part of our everyday lives and technology. All right, that's it for today's magnetic adventure. Hope you had fun and learned something new. If you enjoyed this video, don't forget to like, share, and subscribe for more awesome science content. Catch you in the next one.
A dazzling puzzle. The zebra's coat. Zebras are instantly recognizable. Their black and white stripes are unique in the animal kingdom. But why do zebras have these stripes? For many years, scientists have been trying to solve this puzzle. There are many different theories, each with its own evidence. It's a question that has baffled naturalists and explorers for centuries. Some believe it's all about camouflage, helping them blend in with the tall grasses of the African savanna. Others suggest it's a way to confuse predators, making it harder to single out an individual zebra when they're in a group. But the mystery goes deeper than that. Could it be that those bold stripes are less about hiding and more about communication? Or perhaps they play a role in regulating body temperature under the scorching African sun? The answer, as we'll discover, may lie in a combination of factors, revealing the incredible adaptations of these fascinating creatures. Nature's camouflage, blending in or standing out. One of the most popular theories is that stripes help zebras camouflage themselves. This might seem strange, as black and white stripes don't seem very good at blending in. However, in the dappled light and long grasses of the savanna, the stripes can make it harder for predators to see them clearly. Imagine a lion stalking a herd of zebras. The stripes can create a confusing optical illusion, making it difficult for the lion to judge distance and speed. This confusion might give zebras the crucial seconds they need to escape. While stripes might not provide perfect camouflage, they certainly make zebras less conspicuous. Especially when they're on the move, the stripes can create a dazzling effect that makes it hard for predators to focus. More than meets the eye stripes for socializing. Zebras are highly social animals, living in herds with complex social structures. Could it be that their stripes play a role in communication and social interaction? Some scientists believe so. Each zebra has a unique stripe pattern, much like a human fingerprint. These unique patterns might help zebras recognize each other within the herd. This is particularly important for foals recognizing their mothers. Furthermore, the stripes might help zebras signal to each other. When a zebra is agitated or threatened, its stripes might appear more pronounced as its muscles tense. This could serve as a warning signal to other zebras in the vicinity. Section 4. Fly away! Stripes that keep pests at bay. In a surprising turn of events, recent research has shed light on a fascinating possibility. Zebra stripes might act as a deterrent against biting flies. These flies, which are a constant nuisance and can carry diseases, are less attracted to the black and white stripes than they are to solid colors. Studies have shown that flies, particularly tsetse flies, have a harder time landing on striped surfaces. The stripes seem to confuse their visual system, making it difficult for them to control their approach. This might explain why zebras, which are particularly susceptible to fly-borne diseases, have evolved such a distinctive pattern. This unexpected benefit of having stripes adds another layer to the complex story of zebra evolution. It demonstrates how even the most striking features can serve multiple purposes, highlighting the incredible adaptability of nature. Section 5. The zebra's secret code, unraveling the mystery. So, why do zebras have stripes? It's likely a combination of factors. Camouflage, predator confusion, social recognition, and even insect repellent all play a role. Each theory contributes to our understanding of these fascinating creatures. The zebra's stripes remain one of nature's most intriguing puzzles. While we may never have a definitive answer, the ongoing research and debate only deepen our appreciation for the wonders of the natural world. The zebra, with its bold stripes, reminds us that there's always more to discover. The animal kingdom is full of surprises, and it's up to us to unravel its mysteries.
Spinning. It's something we've all experienced at some point in our lives. Whether it's on a playground merry-go-round, dancing in circles, or just goofing around with friends, spinning is a universal joy. It is a lot of fun at first. The laughter, the exhilaration, the carefree moments of joy. We spin around and around, arms outstretched, feeling the wind rush past us. The world becomes a blur. Colors and shapes merge into a dizzying whirl. Then we stop, and everything feels strange. We feel dizzy, unsteady on our feet. The world seems to be moving even though we are standing still. It's a disorienting sensation. Why does this happen? What is going on inside our heads? How does spinning affect our sense of balance and perception? The answer lies in our inner ear, a tiny part of our body that plays a big role in how we experience the world. This intricate system is crucial for maintaining our balance. The inner ear is responsible for our sense of balance, telling us which way is up and which way is down. It helps us stay upright and move smoothly. From walking to dancing, our inner ear ensures we maintain our equilibrium. But when we spin, we confuse our inner ear. The fluid inside the canals of our inner ear continues to move, sending mixed signals to our brain. Let's find out how this fascinating process works. Deep inside our ears, beyond the eardrum, lies the inner ear. This intricate part of our anatomy is not just responsible for hearing, but also plays a crucial role in maintaining our balance. It is a complex structure filled with fluid and tiny hairs. These tiny hairs, known as cilia, move with the fluid and send signals to our brain about our body's position and movement. The inner ear has different parts, each with its own specific function. These parts work together to help us interpret sound and maintain equilibrium. One part, the cochlea, helps us hear. It converts sound waves into electrical signals that our brain can understand. Another part, the vestibular system, helps us keep our balance. It detects changes in head position and motion. This part is called the vestibular system. It consists of several interconnected structures that work together to provide us with a sense of balance. Inside the vestibular system are 3 small loops called semicircular canals. These canals are crucial for detecting rotational movements. These canals are positioned at right angles to each other, like the floor and 2 walls meeting in a corner. This unique arrangement allows them to sense movement in 3-dimensional space. This arrangement allows the canals to detect movement in any direction. When we move our head, the fluid inside these canals shifts, bending the cilia and sending signals to our brain. The canals are filled with a special fluid called endolymph. This fluid's movement is what helps the semicircular canals detect changes in our head's position and motion, ensuring we maintain our balance. When we spin, the fluid in our semicircular canals starts to move. Imagine a glass of water. If you turn the glass slowly, the water inside will also turn. The same thing happens in our ears. When we spin, the endolymph in our semicircular canals lags behind the movement of our head. This movement of fluid bends tiny hairs that line the canals. These hairs are very sensitive. Even a small amount of movement can trigger them. The hairs send signals to our brain, telling it that we are spinning. Section 4. Signals to the brain, dizziness takes hold. Our brain relies on the signals from our inner ear to understand our body's position and movement. The inner ear contains structures like the semicircular canals, which are filled with fluid and lined with tiny hair cells. These hair cells move with the fluid, sending signals to the brain about our head's orientation and motion. When we spin, the signals from our semicircular canals become confused. The fluid inside the canals continues to move even after we stop spinning, causing the hair cells to keep sending signals of motion to the brain. The brain receives conflicting information. It gets signals that we are still moving, even though our eyes and other senses tell us we have stopped. It is not sure which way is up or down. This disorientation can make it difficult to maintain our balance and sense of direction. This confusion leads to the sensation of dizziness. The brain's struggle to reconcile these mixed signals results in a spinning or swaying feeling. We may feel lightheaded, unsteady, or even nauseous. These symptoms are the body's way of responding to the brain's attempt to make sense of the conflicting information. Our eyes may also move involuntarily, trying to compensate for the conflicting signals. This involuntary eye movement is known as nystagmus. This is called nystagmus, and it is another sign that our brain is struggling to make sense of the situation. Nystagmus can make it even harder to focus and can contribute to the overall feeling of dizziness and disorientation. Section 5. Conclusion. A final spin. Dizziness after spinning is a common experience. It is caused by the movement of fluid in our inner ears. This fluid movement sends confusing signals to our brain, leading to the feeling of dizziness. Fun fact: did you know that astronauts experience dizziness in space? This is because in the absence of gravity, the fluid in their inner ears does not behave the same way as it does on Earth. Summer's heat fades, days grow shorter, the air turns crisp, the vibrant greens of summer begin to transform into a kaleidoscope of colors. It's a magical time of year when nature starts to prepare for the colder months ahead. Nature is putting on a spectacular show. The leaves are changing color. This transformation is a visual feast, with each tree contributing to the grand display. From vibrant yellows to fiery oranges and deep reds, the landscape is painted with a rich palette of autumn hues. Each leaf tells a story of the season's change. Trees are adorned in their autumn finest, showcasing their beauty before the winter sets in. It's a final burst of color before the world turns monochrome. But this colorful display is more than just a pretty sight. It's a crucial part of the tree's life cycle, signaling the end of one phase and the beginning of another. It's a sign that trees are preparing for a long winter's nap. As the days grow shorter and temperatures drop, trees begin to conserve their energy. As summer ends, trees start to slow down their food production. They begin to break down the green chlorophyll in their leaves, revealing the hidden colors beneath. They can't make food without sunlight, and there's less of it as days grow shorter. This reduction in light triggers the trees to prepare for dormancy. So, trees prepare to shed their leaves, their food factories, and rest until spring. This process ensures they survive the harsh winter and emerge ready to grow again when the warmth returns. The vibrant green color of leaves comes from a pigment called chlorophyll. This pigment is crucial for the process of photosynthesis, which allows plants to convert sunlight into the energy they need to grow and thrive. Chlorophyll helps trees capture sunlight and turn it into energy through photosynthesis. This process not only sustains the tree, but also produces oxygen, which is essential for life on Earth. As autumn approaches, trees begin to prepare for the colder months. They break down chlorophyll and reabsorb its valuable nutrients, like nitrogen and phosphorus, to store for the winter. This process is essential for the tree's survival during the harsh conditions of winter. As chlorophyll disappears, other pigments that were hidden within the leaves all summer long become visible. These pigments have been there all along, but the dominant green of chlorophyll masked them. Carotenoids, responsible for the yellows and oranges, are always present in the leaves but are usually overshadowed by the green chlorophyll. When chlorophyll breaks down, these vibrant colors come to the forefront. Anthocyanins, which produce reds and purples, are actually made in the autumn from leftover sugars trapped in the leaves. These pigments add to the rich tapestry of colors we see during the fall season. This intricate process of pigment breakdown and nutrient reabsorption is what creates the stunning and diverse array of autumn colors. It's a beautiful reminder of the complex and fascinating cycles of nature. Shedding leaves is crucial for trees to survive harsh winter conditions. Leaves are like solar panels, great for absorbing sunlight but also prone to losing water. In winter, frozen ground makes it difficult for trees to absorb water. By shedding leaves, trees reduce water loss through transpiration. The abscission layer, a thin layer of cells at the base of each leaf stalk, gradually seals off the connection between the leaf and the branch. Eventually, the leaf detaches and falls, leaving behind a leaf scar on the branch. Section 4. Evergreen champions trees that keep their leaves. While many trees shed their leaves in autumn, some called evergreens keep their foliage year-round. These trees have special adaptations that allow them to survive winter with their leaves intact. Conifers, like pine and fir trees, have needle-shaped leaves with a waxy coating that minimizes water loss. They also have antifreeze-like substances in their sap to prevent freezing. These adaptations allow evergreens to photosynthesize and grow even during milder winter days when deciduous trees are dormant. Section 5. Fallen leaves, nature's winter blanket. Fallen leaves might seem like waste, but they play a vital role in forest ecosystems. These leaves, once part of the vibrant canopy, now create a rich tapestry on the forest floor. They are not just discarded remnants of the past season, but rather, they are the foundation for future growth and renewal. As they decompose, they release their stored nutrients back into the soil, providing essential nourishment for future generations of trees and other plants. This process of decomposition is a slow and steady transformation, turning what was once living into a source of life for the forest floor. The nutrients released are crucial for the health of the ecosystem. This layer of decomposing leaves also acts as a natural mulch, insulating the ground and protecting tree roots from freezing temperatures. The insulating layer helps to maintain a stable temperature in the soil, which is vital for the survival of many plant species during the harsh winter months. It provides shelter for insects, amphibians, and other small creatures seeking refuge from the cold. These leaves create a microhabitat, offering warmth and protection, ensuring that even the smallest inhabitants of the forest can survive the winter. So, while we might miss the vibrant colors of autumn leaves, their fall signifies the cycle of life continuing in the forest, even during the quiet months of winter. The fallen leaves are a reminder that every end is a new beginning, and the forest is always preparing for the next season of growth and renewal. Alright everyone, let's dive into one of the coolest mysteries of everyday life: shadows. Have you ever wondered why shadows follow you everywhere? It's like they're your silent companions, always sticking around. Well, let's unravel this mystery. First, what exactly is a shadow? A shadow is simply a dark area where light is blocked by an object. It's that easy. When light from a source like the sun, a lamp, or even your phone's flashlight hits an object, it can't pass through it. So it creates a shadow on the other side. Think about this. When you stand in the sunlight, your body blocks some of the sunlight, creating a shadow on the ground. Now, why does this shadow seem to follow you? It's because the position of your body determines where the light is blocked. Move your body, and the light-blocked area moves too. Hence, your shadow follows. Ever notice how shadows change throughout the day? In the morning, shadows are long and stretch out behind objects. At noon, when the sun is directly overhead, shadows become short and stick close to you. And in the evening, they elongate again. It's all about the angle of the light source. Now, here's something fun. Shadows aren't always perfectly dark. Have you seen those blurry, less defined edges around a shadow? That's because light can bend around the edges of objects, causing the shadow to have a gradient, a mix of light and dark areas. Ever tried making shadow puppets? It's the same principle. By changing the distance between your hands and the light source, you can make your shadow larger or smaller. Here's a cool experiment you can try at home. Grab a flashlight and a few objects like toys or books. Shine the flashlight on the objects and move it around. Watch how the shadows grow, shrink, and change direction. It's like magic, but it's all about physics. So, the next time you see your shadow, remember this. It's just light playing its usual trick, blocked by you. Shadows are a constant reminder of how light interacts with the world around us. And there you have it. The mystery of shadows is not so mysterious after all. They're just playful copies made by light, following you around as you explore the world. Thanks for joining me in this quick dive into the world of shadows. Don't forget to like, subscribe, and share this video with your friends. Stay curious and keep exploring. See you next time.
Have you ever stopped to think about how often you blink? It's something we do without even realizing it, a constant rhythm in the background of our daily lives. But this seemingly insignificant action serves a crucial purpose: maintaining the health and function of our eyes. Blinking might seem like a simple thing, but it's a vital part of what allows us to experience the world around us. The primary reason we blink so much is to keep our eyes lubricated. Blinking is an automatic reflex that happens without us even thinking about it. On average, a person blinks around 15 to 20 times per minute. This means that in a single day, we blink thousands of times. But why is this simple action so crucial for our eye health? Every time we blink, our eyelids spread a thin layer of tears across the surface of our eyes. This tear film is essential for maintaining the health of our eyes. It not only keeps the eyes moist, but also helps to clear away small debris and dust particles that can cause irritation. These tears aren't just water. They contain oils and mucus that help to keep our eyes moist and comfortable. The oils prevent the tears from evaporating too quickly, while the mucus ensures that the tears spread evenly across the surface of the eye. This complex mixture is what keeps our eyes feeling fresh and comfortable throughout the day. Without this constant lubrication, our eyes would become dry and irritated, making it difficult to see clearly. Dry eyes can lead to discomfort, redness, and even blurred vision. It's a condition that can significantly impact our daily lives, making simple tasks like reading or watching TV a challenge. Imagine staring at a computer screen for hours without blinking. Your eyes would feel dry and strained. This is why it's so important to take regular breaks and remember to blink, especially when using digital devices. Blinking helps to refresh the eyes and reduce the risk of digital eye strain. Blinking provides the necessary relief, ensuring our vision stays sharp. It's a simple yet vital action that we often take for granted. So, the next time you blink, remember that this small act is your eye's best friend, working tirelessly to keep your vision clear and your eyes healthy. Blinking isn't just about keeping our eyes moist, it also acts as our eyes' first line of defense against the outside world. Our eyes are constantly bombarded with dust, debris, and other foreign particles that float through the air. Each blink acts like a windshield wiper, sweeping away these potential irritants before they can scratch or damage the delicate surface of our eyes. This protective mechanism is essential for maintaining clear vision and preventing infections. Section 4. Beyond moisture, the brain's blink connection. Interestingly, blinking isn't just about eye health, it also plays a role in brain function. When we blink, it's not merely to keep our eyes moist and free from irritants. There's a fascinating neurological aspect to this seemingly mundane action. Studies have shown that our brains actually take a micro break every time we blink. These micro breaks are incredibly brief, often lasting just a fraction of a second, but they are crucial for maintaining cognitive function. These micro breaks are so short that we don't even notice them, but they allow our brains to momentarily rest and recharge. This brief pause can help reset our attention and improve our focus, making us more efficient in our tasks. This might explain why we tend to blink more when we're tired or mentally fatigued. When our brains are overworked, they signal us to take these tiny breaks more frequently, helping to alleviate some of the mental strain. Our brains are telling us to take a break, and blinking provides a quick and easy way to do just that. So, the next time you find yourself blinking more often, remember that it's your brain's way of taking a much-needed pause. Section 5. Blinking through life facts and figures. Here are some fascinating facts about blinking, a seemingly simple yet incredibly vital function of our bodies. On average, people blink around 15 to 20 times per minute. This means that in just 1 hour, you might blink about 900 to 1200 times. That adds up to over 10,000 blinks per day. Imagine the number of blinks in a year. It's over 5 million. Interestingly, babies blink much less frequently than adults, only a few times per minute. This is because their eyes are more sensitive and need more time to adjust to the world around them. We also tend to blink less when we focus on a task, like reading or driving. This is because our brain prioritizes the task at hand, reducing the frequency of blinks to maintain concentration. Blinking is an essential part of what makes us human. It helps to keep our eyes moist and free from dust and other irritants. It's a small action with a big impact, keeping our eyes healthy, our brains alert, and our vision clear. Without blinking, our eyes would dry out and become susceptible to infections. So next time you blink, take a moment to appreciate this amazing ability. It's a reminder of how our bodies are designed to protect and sustain us in the most subtle yet profound ways.
Have you ever gulped down a cold drink or devoured ice cream too quickly? Suddenly, a sharp stabbing pain shoots through your head. Ouch! That, my friends, is the dreaded brain freeze. It's a common experience, and thankfully, it's temporary. But what causes this strange sensation in our heads? Let's dive in and explore the science behind brain freeze. Believe it or not, the pain of a brain freeze isn't actually in your brain. Our brains don't have pain receptors. Instead, it's the blood vessels and nerves in our mouths and throats that are responsible for this icy headache. When something very cold touches the roof of your mouth, it causes the blood vessels there to constrict quickly. This is like a traffic jam suddenly forming in your blood vessels. As we learned, the trouble starts when something very cold touches a specific spot on the roof of your mouth called the anterior palate. This area is particularly sensitive and reacts almost instantly to sudden temperature changes. Imagine taking a big bite of ice cream or sipping on a frosty drink. The cold sensation hits this spot and sets off a chain reaction. This area is very sensitive to temperature changes. The anterior palate is packed with nerve endings that are quick to respond to any shift in temperature, especially when it drops suddenly. This sensitivity is what makes the experience so intense. When it gets cold too quickly, the blood vessels there constrict to minimize heat loss. This is the body's natural defense mechanism to protect the brain and maintain its core temperature. The constriction happens almost immediately, causing a brief but noticeable discomfort. Then just as quickly, they dilate again to warm back up. This rapid change from constriction to dilation is the body's way of balancing the sudden temperature drop. The dilation helps to restore normal blood flow and bring warmth back to the affected area. This rapid constricting and dilating of blood vessels is what triggers the pain signals we feel as brain freeze. The nerves in the anterior palate send these pain signals to the brain, creating that sharp, sudden headache we all know too well. It's a brief but intense reminder of how sensitive our bodies can be to temperature changes. Section 4. Understanding the chill. Comparisons to make it clear. Imagine a balloon inflating and deflating rapidly. This simple yet vivid image can help us understand the dynamic changes happening within our bodies. That's similar to what's happening to your blood vessels during a brain freeze. When you consume something extremely cold, your blood vessels in the roof of your mouth undergo rapid expansion and contraction. The quick changes in pressure create a signal that is sent to your brain through the trigeminal nerve. This nerve acts like a messenger, transmitting the sensation of cold from your mouth to your brain. This nerve is responsible for sensation in your face and head. It plays a crucial role in how we perceive different types of sensations, including pain and temperature. It's the same nerve that gives you a headache. When the trigeminal nerve is stimulated by the rapid changes in temperature, it can cause a sudden, sharp pain in your head. So, the next time you experience brain freeze, remember that it's just your trigeminal nerve doing its job, albeit in a slightly dramatic way. This understanding can help you appreciate the complex and fascinating ways our bodies respond to different stimuli. Section 5. Outsmarting the freeze tips to avoid the big chill. We've all been there enjoying a delicious ice cream or a refreshing cold drink, when suddenly, a sharp pain hits our head. This is what we call brain freeze, and while it's a common experience, it can be quite uncomfortable. Luckily, brain freeze is harmless and temporary. It's your body's way of telling you that something cold has hit the roof of your mouth too quickly. The good news is, there are ways to prevent it, but if you'd rather avoid it altogether, here are some simple tips. First, slow down. Eating or drinking cold items too quickly is the main culprit behind brain freeze. By taking your time, you give your mouth a chance to adjust to the cold temperature. This is the most important tip. Savor your ice cream or cold drink slowly, and you'll reduce the risk of that sudden sharp pain. Don't gulp down that ice-cold drink or gobble up that ice cream too quickly. Rapid consumption is a sure way to trigger brain freeze. Give your mouth time to adjust to the cold temperature. Second, warm up. If you do feel the onset of brain freeze, there are quick remedies you can try. Press your tongue against the roof of your mouth to warm up the area. This simple action can help to alleviate the pain by warming the nerves that are sending those pain signals to your brain. This helps to counteract the rapid cooling effect. Third, breathe warm air. This might sound a bit unusual, but it works. Try breathing in through your nose and out through your mouth. This technique helps to warm the back of your throat, which can reduce the chance of a brain freeze. This can help to warm up the back of your throat and reduce the chance of a brain freeze. By warming the area, you can prevent the cold from triggering those pain receptors. Remember, brain freeze is a fascinating example of how our bodies react to changes in temperature. It's a protective mechanism, albeit a painful one. So the next time you feel that familiar pang in your head, don't panic. Instead, use these tips to quickly alleviate the discomfort. Just take a deep breath, warm up your mouth, and remember the amazing science happening inside you. Understanding why brain freeze happens and knowing how to counteract it can make your cold treat experiences much more enjoyable.
All right, folks, let's dive into the deep blue and unravel the secrets of ocean tides. The rhythmic dance of the ocean is not just a mesmerizing sight, but a fascinating phenomenon driven by forces beyond our immediate perception. Ever wonder why the ocean's water moves in and out? It's like the ocean has a heartbeat, a pulse that never stops. Why sometimes the beach is a sprawling sandbox, and other times it's a swimmer's paradise. This constant change is a result of the gravitational forces at play. Well, stick around, because I'm about to break it down for you. We're going to explore the science behind these incredible movements. So first off, what are tides? They are not just random waves, but a predictable and regular phenomenon. Tides are the regular rise and fall of sea levels, caused by the gravitational forces exerted by the moon and the sun and the rotation of the earth. This interplay of forces creates a dynamic and ever-changing ocean landscape. Picture the ocean as this giant, squishy water balloon. When you squeeze one side, the other side bulges out. When the moon's gravity pulls on it, it creates these bulges of water. We call these bulges high tides. These bulges are the ocean's response to the moon's gravitational pull. Now you might be thinking, okay, but if the moon's pulling the water, why do we see two high tides every day? It's a bit more complex than it seems. Great question. This is where the Earth's rotation and the concept of inertia come into play. While the moon pulls the water towards it, there's also a bulge on the opposite side of the Earth. This is due to the inertia of the water. This happens because of the inertia of the water. Basically, it's the water's resistance to change its state of motion. The water on the far side of the Earth resists the pull and creates a second bulge. But wait, there's more. The story of tides doesn't end with the moon. The sun also gets in on the action. Its gravitational pull, though weaker than the moon's due to the greater distance, still plays a significant role. Even though it's much further away, the sun's gravitational pull still affects our tides. It works together with the moon to create the tidal patterns we observe. When the sun, moon, and Earth are in a straight line during full moons and new moons, we get these super high tides called spring tides. These are the highest tides we experience. And when they're at right angles, during the first and last quarters of the moon, we get neap tides, which are lower high tides. These tides are less extreme but equally important. Now, tides aren't just fascinating, they're also incredibly important. They play a crucial role in our environment and daily lives. They help regulate the coastal ecosystems, bring in nutrients, and even assist in navigation for ships. The movement of tides ensures that marine life thrives and that our coastlines remain healthy. Plus, tidal energy is a promising source of renewable power. Harnessing the power of tides could provide a sustainable energy solution for the future. But tides can be tricky too. They don't behave the same way everywhere. Places experience dramatic tidal changes, while others hardly notice. This variation is due to several factors. This all depends on the coastline shape, ocean floor, and other local factors like the Earth's rotation. Each coastline has its unique tidal signature. So next time you're at the beach and you see the water inching closer or pulling away, take a moment to appreciate the science behind it. Remember, it's not magic, it's science. The intricate dance of gravitational forces is what makes our oceans move. The moon, the sun, and our spinning Earth are all working together to keep our oceans dancing. It's a beautiful and complex system that keeps our planet in balance. Alright, that's all for today, folks. I hope you enjoyed this exploration of ocean tides. If you enjoyed this deep dive into ocean tides, hit that like button and subscribe for more cool science topics. Your support helps us bring more fascinating content to you. Stay curious, keep exploring the wonders of our world. See you next time. Until then, keep wondering and keep learning.
Have you ever wondered what happens in the world while you sleep? As the sun sets and darkness falls, a whole new world comes to life. This is the world of nocturnal animals, creatures that thrive under the cover of night. Imagine a world of hushed whispers and rustling leaves where shadows dance and the moon acts as a guiding light. This is the reality for nocturnal animals, a world teeming with activity and hidden wonders. Why do some animals prefer the night? The answer often lies in survival. Nocturnality, as it's called, offers many advantages. For some animals, the cool, dark night provides a welcome escape from the scorching daytime heat. For others, the cover of darkness offers protection from predators. By venturing out at night, these animals can avoid the sharp eyes of daytime hunters and increase their chances of survival. To navigate the darkness, nocturnal animals have evolved extraordinary adaptations. These creatures have developed unique traits that allow them to thrive in environments where light is scarce. Their senses are finely tuned to the challenges of the night. Take owls, for example. These majestic birds are masters of the night sky. Their large eyes facing forward like ours allow them to capture even the faintest glimmer of light. This adaptation is crucial for spotting prey in near-total darkness. Owls also have exceptional hearing. Their ability to detect the slightest rustle of a mouse or the flutter of a moth is unparalleled. Their ears are positioned asymmetrically on their heads, allowing them to pinpoint the exact location of prey with incredible accuracy. This unique ear placement gives them a three-dimensional auditory map of their surroundings. This is just one example of the many ways nocturnal animals have adapted to their environment. From the silent flight of bats to the keen sense of smell in foxes, each species has its own set of tools for survival in the dark. These adaptations highlight the incredible diversity and ingenuity of life on Earth. Section 4. Creatures of the night: owls, bats, and more. The night is a mysterious and fascinating time, teeming with life that many of us rarely see. As the sun sets and darkness envelops the world, a different kind of activity begins. The animal kingdom is full of fascinating nocturnal creatures. These animals have adapted to thrive in the dark, using their unique abilities to hunt, navigate, and survive. Bats, with their echolocation abilities, navigate and hunt insects in complete darkness. They are like the night's own radar systems, sending out high-frequency sounds that bounce back to reveal the location of their prey. They emit high-pitched sounds that bounce off objects, allowing them to see their surroundings. This incredible adaptation makes them efficient hunters, even in the pitch-black night. Then there are the stealthy hunters like leopards and foxes. These predators rely on their keen senses and silent movements to stalk their prey under the cover of darkness. Their sleek bodies and sharp senses make them formidable predators under the cloak of night. Their eyes are adapted to see in low light, and their hearing is finely tuned to detect the slightest rustle. From the smallest insects to the largest mammals, the night is alive with a diverse range of creatures. Each has its own role to play in the nighttime ecosystem, creating a vibrant and dynamic world that comes to life when the sun goes down. Section 5. The balance of nature: nocturnality's vital role. Nocturnality plays a crucial role in maintaining the delicate balance of nature. Many animals have evolved to be active during the night to avoid predators, find food, and mate. This behavior helps reduce competition for resources, as different species can occupy the same habitat without directly interfering with each other. For instance, owls hunt at night while hawks hunt during the day, allowing both to thrive in the same environment. This division of time ensures that ecosystems remain balanced and diverse. By being active at different times, nocturnal and diurnal or daytime, animals can share resources and habitats without directly competing. This temporal separation is crucial for the survival of many species. It allows for a more efficient use of the environment, where each creature has its own time to shine. The night becomes a stage for a different set of actors, each playing their part in the grand play of life. The next time you step outside on a clear night, look up at the stars and remember the hidden world bustling below. While we sleep, a myriad of creatures are going about their lives, contributing to the intricate web of life. From the smallest insects to the largest mammals, each has a role to play in maintaining the health of our planet. The nocturnal world, with its fascinating creatures and their remarkable adaptations, reminds us of the incredible diversity and wonder of the natural world. These animals have developed unique traits to survive and thrive in the darkness, from enhanced senses to specialized hunting techniques. Their existence is a testament to the resilience and adaptability of life on Earth. So let us appreciate and protect this hidden world, for it is an integral part of the natural balance that sustains us all.
Money. It's something we encounter every single day, whether we're buying groceries, paying for a coffee, or even just saving up for something special. We use it every day, in countless transactions, big and small. But what is it really? Have you ever stopped to think about what money actually represents? In simple terms, money is anything we agree has value. It's a mutual understanding that this piece of paper or metal can be exchanged for goods and services. It's a medium of exchange, a tool that facilitates trade and commerce. We use it to buy and sell goods and services. Money simplifies trade, making it easier than bartering. Imagine trading a cow for a cartload of apples. Money makes life easier by providing a common ground for value. Money comes in many forms, from physical coins and banknotes to digital currencies. We use coins, banknotes, and digital currency. Each form has its own unique advantages and uses. It's a fascinating concept that has shaped civilizations throughout history, evolving from simple barter systems to complex financial networks. Understanding money is key to understanding our world today. It influences economies, cultures, and even our daily lives in profound ways. Long ago, there was no money. People lived in small communities and relied on each other for their needs. People exchanged goods and services directly. This was called bartering. If you had something someone else needed, you could trade it for something you needed. Imagine needing a new axe but only having grain to trade. You'd have to find someone who not only had an axe but also wanted your grain. This process could be time-consuming and complicated. You had to find the perfect match for your trade. It wasn't easy. The barter system had its limitations, especially when it came to finding someone with matching needs. Over time, people started using specific items as a medium of exchange. These items were chosen because they had value and were widely accepted. Shells, beads, and salt were early forms of money. They were portable and could be easily divided into smaller units. These objects were durable, divisible, and relatively scarce. Their value was recognized by many, making trade simpler. This made them suitable for trade. People could now exchange goods more efficiently and with less hassle. The invention of coins was a major development. Coins were made from metals like gold, silver, and bronze, which had intrinsic value. Metals like gold and silver became standardized forms of money. They were durable, easy to carry, and had a consistent value. Paper money came later, backed by governments and their gold reserves. This made transactions even more convenient and allowed for larger trades. Today, we're in the digital age. Money has evolved from physical coins and notes to digital transactions and online banking. Cryptocurrencies like Bitcoin are changing the way we think about money. They offer a decentralized and secure way to conduct transactions, paving the way for the future of finance. Why did certain items become valuable as money? Gold and silver were durable. They didn't decay. They were also divisible. They could be melted and made into coins of different sizes. Scarcity was crucial. Rare items held greater value. Paper money, on the other hand, gets its value from trust. We trust that the government guarantees its worth. The history of money is a testament to human ingenuity. We've constantly sought better ways to facilitate trade. Section 4. Trust. The invisible force behind money's might. Money works because we trust it. We trust that others will accept it as payment. This trust is based on social conventions and government regulations. We believe that the value of our money will remain relatively stable. Without trust, money is just paper and metal. Imagine if everyone stopped accepting dollars tomorrow. The entire financial system would collapse. Trust is the bedrock of our economic system. Section 5. Money in our modern world, a force to be reckoned with. Money plays a central role in our modern world. It drives global trade, fuels innovation, and shapes our aspirations. From bustling stock markets to the intricate logistics of international shipping, money is the lifeblood that keeps the wheels of commerce turning. It is the catalyst for groundbreaking technological advancements and the force behind ambitious projects that push the boundaries of what is possible. It allows us to specialize in our work, enabling professionals to hone their skills and contribute to a diverse economy. Skilled workers in various fields can focus on their expertise, knowing that their efforts will be rewarded through the economic system and trade for our needs. This exchange of goods and services is the foundation of our daily lives, from the bustling marketplaces to the convenience of modern supermarkets. However, money also has its downsides. It can create significant disparities in wealth and opportunity, leaving some individuals marginalized and struggling to make ends meet. Economic policies and systems can sometimes exacerbate these issues, leading to social unrest and protests. It can contribute to inequality and fuel conflict. The gap between the rich and the poor can lead to tensions and conflicts, both within and between nations, as resources become unevenly distributed. Understanding money is crucial for navigating the complexities of the 21st century. Education in economics and financial literacy empowers individuals to make informed decisions, whether they are students preparing for the future or professionals strategizing in the boardroom. As we move towards a digital future, the landscape of money is rapidly changing. Digital currencies and mobile payment systems are revolutionizing the way we conduct transactions, making financial interactions more seamless and accessible. The concept of money will continue to evolve. Innovations in financial technology are paving the way for new forms of currency and payment methods, challenging traditional notions of money and finance. One thing is certain: money will continue to shape our world in profound ways. As we navigate the complexities of the global economy, understanding the dynamics of money will be more important than ever, influencing everything from individual livelihoods to international relations.